Give an older AI a hard logic puzzle or a tricky math problem, and it would fire back an answer instantly. Confident, fast, and often completely wrong. Then, around late 2024, a new kind of model showed up that did something almost unsettling. You would ask it the same hard question and it would pause, think for 10 seconds, 30, sometimes minutes, and come back dramatically more likely to be right. It had not gotten any bigger. It had learned to think before it speaks. So how do you teach a next-word predictor to actually reason? And why on earth does simply letting it think longer make it smarter? Start with why the old way fell apart on hard problems. Remember the core loop. The model writes one word at a time, strictly left to right, with no take-backs. So if a problem genuinely needs 5 careful steps of work, but the model commits to its final answer in the very first breath, it is basically blurting the conclusion before doing any of the work. Imagine being forced to shout the answer to a hard puzzle the instant you hear it. No scratch paper, no pause to think. For easy questions, fine. For hard ones, that is a recipe for confident nonsense. And the fix, once you hear it, sounds almost too obvious. Let it use scratch paper. And here is the lovely part. The scratch paper is just more words. Remember that every word the model writes immediately becomes part of what it reads to choose the next word. So if you let it first write out its thinking, step 1, step 2, let me check that, before committing to a final answer, then by the time it reaches that answer, it has its own worked-out reasoning sitting right there in front of it to lean on. The thinking literally becomes context for the conclusion. Each step it writes makes the next step a little easier to get right. People first stumbled onto this by simply asking the model to think step by step. But that was just a prompt, a nudge. The real leap was training a model to do this on its own, every time and deeply. So how do you train that habit in? This is where last episode pays off directly. Remember the newest kind of reward, the one where you do not need human taste because you can just check whether the answer is correct. Math has a right answer. Code either passes its tests or it does not, so you do exactly this. Hand the model a hard problem. Let it ramble out a long chain of reasoning any way it likes, however it wants to get there, and then check only the final answer. Right? Reward it. Wrong. No reward. You never grade the individual steps. You never tell it how to think. You only reward reaching the correct destination, and then you let it figure out, across millions of problems, what kinds of thinking actually tend to get there. And what the model discovers entirely on its own is the remarkable part. Nobody teaches it to double-check its arithmetic. Nobody teaches it to back up when it is stuck. But because those exact habits lead to more correct answers, and correct answers are the only thing rewarded, the model gradually teaches itself to do them. It starts writing things like, "Wait, let me reconsider that," catching its own mistakes halfway through, abandoning a dead end and trying a fresh approach. Researchers watching this emerge described a striking moment where a model seemed to spontaneously learn to stop and rethink, though just how dramatic that moment really is still debated. Now, one honest thing about what I am drawing. I am showing this as a branching tree to make the idea visible, but the model's actual output is a single straight stream of words. The backtracking happens inside that stream. The wait, no, actually, not by exploring some literal tree in space. And this unlocks something genuinely new, a second lever for making AI smarter. The first lever, the one we have known all along, is scale. Bigger model, more training, more upfront cost, paid once before you ever use it. But this is different. Now you can make a model perform better on a hard problem simply by letting it think longer at the moment you ask, spend more words, more seconds working it through. More thinking at answer time directly buys more accuracy. Watch the compute meter and the accuracy curve climb together. This is a brand new dimension, and it is why these models can grind away for minutes on a hard proof, and why they cost more to run on the hard questions. You are not paying for a bigger brain. You are paying for more thinking time. Now, 2 honest cautions, because this is the most hyped and most misread corner of all of AI. First, Do not picture a little conscious mind in there, muttering to itself. That visible chain of thought is the model generating reasoning-shaped text, because that kind of text leads to better answers. And unsettlingly, careful studies show the written-out reasoning is not always a faithful record of what actually drove the answer. Sometimes it is more like a story told after the fact. Useful to read, but not a clear glass window into its mind. Second, this does not make it reason like a human, and it does not guarantee it is right. It helps enormously on problems with checkable steps, math, code, logic, and far less where there is no clean way to verify the answer. It is a powerful technique. It is not magic, and it is not consciousness. So a reasoning model is not a bigger brain. It is a model taught, purely by reward, to think on paper before it answers, to spend more effort on the harder problems, and to catch its own mistakes, all because reaching the checkably correct answer was the only thing it ever got rewarded for. And it opened a second road to smarter AI, not just train bigger, but think longer. But all of this thinking, the long chains of reasoning, the back and forth of a conversation, the documents you paste in, has to fit somewhere. And that somewhere turns out to be surprisingly small and surprisingly leaky. The model, it turns out, has no memory at all, and even what it can hold it does not use evenly. Next, the context window.